Right, now we're talking about class intervals, class limits, class boundaries, class widths, and midpoints. Right, we're going to define each one of these and we're going to learn how to calculate it. Now, these apply to our group data. Class intervals basically is the range of values grouped together in a frequency table. So in previous examples, we saw classes such as 0 to 4, 5 to 9, 10 to 11. Each of these are intervals that shows data that falls within that particular range, right? So some values could be between 0 to 4 if it was the scores that we're looking at, or 5 to 9 or 10 to 14. Each of them would represent a separate interval. Now, in a class interval, we have limits. We have the smallest and largest values in the class interval, creating somewhat what we refer to as limits. So the interval 5 to 9 has a lower class limit of 5 and an upper class limit of 9. Right? These are the limits. Now, limits are not to be confused with this other one that we're talking about here called boundaries. Boundaries are similar to limits, but they help to further fine-tune or refine where the values in a particular interval would lie. They are basically used to remove gaps between the intervals. So, if we're talking about the interval 5 to 9, right, our limits is 5 to 9, right? But what about if we have a value of 4.6 or maybe 8.7 or 9.3 or even 9.8? How would we know where to put these or which interval to put them in? The boundaries help to clarify these areas. The lower class boundary of any limit, so you need the limits in order to calculate your boundaries, would always be 0.5 less than your lower limit. So for example, the lower boundary in interval 5 to 9 will be 4.5. It's 0.5 less than 5. The upper boundary is plus 0.5 more than your upper limit. So if our upper limit here is 9, then our upper boundary will be 9.5. Now, the way in which we will use this is just finding the limits, but the way in which we will use this requires the use of some inequalities. So we would say for this particular class interval, right, we have upper limit being 9. Our lower limit being 5. When we're talking about boundaries, our upper boundary, and we refer to it as upper class boundary because it's a class interval, will be 0.5 more than that limit, so 9.5. And our lower class boundary will be 4.5, 0.5 less. Now, if X is whatever data we are observing, when we look at the class interval 5 to 9, values that are less than 9.5 but greater than or equal to 4.5 could fall inside of this class 5 to 9. What this means is that we could go all the way up to 9.49 and it will still fall inside of this class 5 to 9. But if we go over let's say we go to use another color, 9.63. 9.63, because it is more than 9.5, it will go to this class, whose boundaries would be greater than or equal to 9.5, but less than 14. So 9.63 would belong to the 10 to 14 class, right? But 9.49 will belong to the 5 to 9 class because it is less than 9.5. Everybody understand that? Anybody doesn't, just give me a thumbs down. right? So the key thing here, the key takeaway with boundaries are these inequality signs, and that the boundaries are always 0.5 lower than your lower limit or 0.5 more than your upper limit, right? Now, these are very important when we need to calculate the mean for group data. Class width. The class width describes the size of each class interval, right? And it could be found in two ways. We could either take our upper class limit minus our lower class limit and add 1 to it. This is the less common method of calculating class width. The more common method would be to take your upper boundary and subtract your lower boundary from it. So if we had the same 10 to 14 class interval, the class width will be 9.5 because this is my lower boundary, right? And my upper boundary will be 14.5. We subtract these two, we're talking about a total of 5. Now, for all of the classes, they will have the same width, right? Classes will have the same width. There wouldn't be different widths between the classes. It should be uniform throughout. Now, whether you use the class width with your upper class limit minus your lower class limit plus 1, or your upper boundary minus your lower boundary, your answer should always yield the same result. Yeah? Midpoints. Midpoints is the middle value in our class interval. Basically, it is the average of your lower and upper boundaries. So if we have the interval 10 to 14, our lower boundary is 9.5, our upper boundary is 14.5, right? We will add these two together, divide that by 2, and that will give us our midpoint, right? Let's check that quickly. So 9.5 plus 14.5, that's a total of 24 divided by 2 will give us 12. Now the midpoints in each class would vary because we have different values to the boundaries. So the 5 to 9 interval, the boundaries are 4.5 and 9.5. So the sum of 4.5 and 9.5 will give us a total of 14 divided by 2 will give us 7. This is another important piece of data because we will use this when we are calculating the mean for group data. All right, so let's recap what we talked about so far. We talked about class intervals, and these are the range of values grouped together in a frequency table. So we're talking mostly group data here. Class interval could be 0 to 4, 5 to 9, 10 to 14. In each of the class intervals, we have limits. These are the smallest and largest values in the class intervals. Then we could further define what will lie in a particular class interval by the use of boundaries. They are used to close the gaps between the intervals, right? The lower boundary will always be 0.5 less than our lower limit. The upper boundary will always be 0.5 more than our upper limit, right? So if we have a class interval such as 15 to 19, our boundaries will be 19.5 and 14.5. 0.5 less than your lower limit, 0.5 more than your upper limit. And we always use the inequality signs to help us identify what will fall in our class. So here we are saying if the data value or data point is greater than or equal to 14.5, but less than 19.5, it will fall into this class. Now, I just want to make a little observation here, right? When we say we close any gaps between each of the points, this is what I mean. Right? Here, look at this, right? In the class 20 to 24, the lower boundary is the same 19.5. It's better when you see them next to each other like this. It's the same 19.5. This one will be 24.5. If I go to the other class, which is 25 to 29, My lower boundary here is 24.5. And my upper boundary is 29.5. Now you might ask, well, why is it repeating? Why is it repeating? Why are we seeing this and this here? This and this here? Although it is repeating, I want you to pay attention to the inequality sign that we see in here. This inequality sign on this side says less than 19.5. This one says equal to 19.5 or more. This says less than 24.5. This one says equal to 24.5 or more. So this is what I mean by closing the gaps, the boundaries close the gaps. If we have a figure that is 19.4, it will fit in this class. But anytime we go to 19.5, if you say 19.52, then 19.52 belongs in this class because it is 19.5 or more. Understand? If we have 29.6, 29.6 does not belong inside of this class. It will have to go to the other class below, which will be a 30 to 34 class, because this is now 29.5 or more, but less than 34.5. Everybody understand that? Well, thumbs up. Anybody do understand that? Just give me a thumbs down. Right. So width, we said the formula that we will prefer to use for width, now that you have mastered boundaries, would be to take your upper boundary and minus your lower boundary from it. The class width will be the same across all of the class intervals. Midpoint is like the average of your boundaries. If we take our lower boundary and our upper boundary and we divide that, you find the sum of that and divide that by 2, that will give us our midpoint of each particular interval. All right. So let's try a little exercise together here. If we have the interval 0 to 4, frequencies 4, 5 to 9, frequency 7, 10 to 14, 5, 15 to 19, we could work out our lower limits and upper limits by looking at each of these class intervals. In this interval, my lower limit is going to be 0, upper limit is 4. Whereas my boundary is going to be negative 0.5, because I have to minus 0.5 from 0. And then my upper boundary will be 4.5, because I have to add 0.5 to 4. Here we'll get a lower boundary of 4.5 and an upper boundary of 9.5. Here I'll get 9.5 as my lower boundary, 14.5 as my upper boundary. You see how it's repeating? Seen it? There's a pattern for us to follow. Right? Now, if we want to find the class width of each of these intervals, using our boundaries, we could calculate our width. The width is going to be the same for all of the intervals, right? So we could do upper limit minus lower limit plus 1. So 0 plus 4 plus 1 will give me 5. 5 and 9 is 14. Sorry, 9 minus 5 is 4 plus 1 will give me 5. 14 minus 10 will give me 4 plus 1 will give me 5. 19 minus 5 will give me 4 plus 1 will give me 5. Right? Now, my midpoints, we are taking our lower and upper class boundaries, adding them together, and then dividing by 2. So 4.5 minus 0.5 will give me 4, divided by 2 will give me 2. 9.5 minus 4.5, that will give me 14. Sorry, we add in, not minus it. 4.5 plus 9.5, that will give me 14, divided by 2, that will give me 7. 14.5 plus 9.5, that will give me a total of 24, divided by 2, that will give me 12. 19.5 plus 14.5, that will give me a total of 34, divided by 2, that will give me 17. All right, and that's how we find midpoints. All right, so for this particular interval, I want you to list to me lower limit, upper limit class boundaries, calculate the class width, and then the midpoints. Yeah? So let's add in lower limit, upper limit. I'm going to abbreviate for boundaries, right? I'm going to write L CB for lower class boundaries, UCB for upper class boundaries, and I'm going to do a column for midpoint. And we'll calculate the width underneath here. All right, so lower limit here is 0, upper limit is 5. Lower limit here is 6, upper limit 10. Lower limit 11, upper limit 15. Lower limit 16, upper limit 20. When we're talking about boundaries, lower boundary here will be negative 0.5. Upper boundary here will be 5.5. Here will be 5.5, 10.5. Here will be 10.5. Here will be 15.5. Here will be 15.5. And here will be 20.5. For my midpoints, I am adding my lower class boundary and upper class boundary and dividing by 2. Right? So if I add this 0.5 minus 0.5, I get 5 divided by 2. 2.5, right? You could also add the limits. I was stating that earlier. If you do 10 and 6 divided by 2, that's 16 over 2. You'll get the same 8. Right? You could either do limits or boundaries here. This will be 26 over 2, which is equal to 13. And this one is 16 plus 20 over 2. That's 36 over 2. That's equal to 18. My width will be our upper class boundary minus our lower class boundary. That's the easier one to do. And you could use any upper class and lower class. Right, you get a total of 5 there for all. Here, let's work out these. Complete with midpoints and boundaries. Midpoints here, again, we could use the limits, right? Limits are fine to use. Add them together, divide by 2. We get 2. 5 plus 9 over 2. 14 over 2, you get 7. 10 plus 14 over 2. 24 over 2, you get 12. 15 plus 19 over 2. You get 20, 34, 17. My boundaries here. I want to write it like this. We didn't write it like this, that's all right. Right, but these are my class boundaries. That's the range within which we fill in the gaps with each of these intervals. The last question here is explain why midpoints are important when calculating the mean for group data. Now, midpoints are important in group data because we don't know the exact value of each data point in a class interval. We just know that there are 3 values that lies between 0 and 4. We don't know if those 3 values is 3 ones, a 3, a 2, and a 4, all 4s, a 2, a 3, and a 4, a 0, a 2, and a 1. We don't know. So what we're actually doing is we're getting an estimate. The midpoint is like an average of that particular class. It's a representative value for that data class. And later on when we're doing mean, we'll estimate the mean by multiplying the midpoint of each class by its frequency. Yeah?